Hello student, welcome to my channel Easy Learning. Today I discuss the determinant. Let us consider one variable simultaneous linear equation. a1x plus b1y equals to 0. a2x plus b2 that is equals to 0. This is equation number 2. So from 1 we evaluate the value of x equals to minus b1 by a1. From 2 we get x equals to minus b2 by a2. From 3 and 4 we compare, we get minus b1 by a1 equals to minus b2 by a2. This implies that b1 by a1 equals to b2 by a2. This implies that a1 b2 minus a2 b1 that is equals to 0. This can be written as this form. This is a1 b1 a2 b2. This is the determinant, which is called a determinant of second order and generally denoted by delta equals to a1 b1 a2 b2, where a1 b1 a2 and b2 are called the elements of the determinant. Again, we consider the three linear simultaneous equations in x and y. a1x plus b1y equals to c1. a1x plus b1y plus c1 equals to 0. Equation number 5. a2x plus b2y plus c2 that is equals to 0. Equation number 6. a3x plus b3y plus c3 that is equals to 0. Equation number 7. So from this equation we can write as this. We just write the coefficient of x, y and constant of the equation 5. Similarly, in the case of equation 6 and 7, as in the determinant, a1 b1 c1, a2 b2 c2, a3 b3 c3, which is called a determinant of the third order, and its value a1 into b2 c3 minus b3 c2 plus b1 into a3 c2 minus a2 c3 plus c1 into a2 b3 minus a2 b3 minus a3 b2. So from these two examples of the determinant, this is the second order determinant, that is a1 b1 a2 b2, and this is the third order determinant, a1 b1 c1, a2 b2 c2, a3 b3 c3. So we first discuss what is determinant. A determinant is an expression or a function of a number which is associated with a square matrix of order n cross n. That is, if capital A equals to Aij n cross n order matrix, that is, this is a number of row equals to number of columns, so this is a n cross n square matrix, then the determinant associated with matrix A is an expression which is denoted by determinant of A or det of A, or determinant of Aij, where I comma j equals to 1 2 3 dot 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 n, that is determinant of A, that is equals to Aij, that is equals to a11 a12 a13 dot 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 a1n a21 a22 a23 dot 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 a2n dot 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 an1 an2 an3 dot 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 ann. This is n cross n. So the determinant associated with the square matrix capital A equals to A11, A12, A21, A22, 2 cross 2. That is, this is 2 cross 2 square matrix. So its corresponding determinant can be written as determinant of A, that is equals to det of A, that is equals to, just symbol is changed. Here we can express within the first bracket or in the third bracket, but it is on this form: A11, A12, A21, A22. And if B equals to B11, B12, B13, B21, B22, B23, B31, B32, B33, it is 3 cross 3 square matrix, then its corresponding determinant can be represented by determinant of B, that is equals to det of B, that is equals to A11, A12, A13, A21, A22, A23, A31, A32, A33. It is a 3 cross 3 determinant. So now we discuss how we can expand this matrix. Expansion of a determinant of the third order. A determinant of the third order can be expressed from any row or any column, and the sign in successive terms of the expansion is given by the rule plus minus plus minus plus minus plus minus plus. That is, if we consider delta or a D, that is equals to A11, A12, A13, A21, A22, A23, A31, A32, A33, 3 cross 3 determinant, 3 cross 3 order determinant. So it can be expanded with any one row or any one column. Now we can expand this determinant with respect to the first row, that is A11. Suppose if you expand this determinant and we write this A11 and we draw a imaginary line along horizontal and along vertical, and we write the uncovered element within the determinant, that is A11 into, if we draw an imaginary line, this and this are the uncovered elements. So it can be written in the determinant form, that is, this is the 2 cross 2 determinant. So A11 into A22, A23, A32, A33. Similarly, this is plus, this is the sign rule. First element, if you expand the determinant with respect to the any one row or any one column, first row if you expand, then first sign is plus, second sign is minus. So this is minus, its element is A12, and we draw a line and we get the uncovered elements A21, A23, A31, A33. It is written in the determinant form, and this is the sign plus as per this rule. So this is plus A13, and similarly we can draw 2 lines and the uncovered element right in the determinant form A21, A22, A31, A32. That is, we write here this process A11 into determinant of the second order obtained by deleting the row and columns through the element A11 minus of A12 into determinant of the second order obtained by deleting the row and column through the element A12 plus A13 into the determinant of the second order by deleting the row and column through A13. Minors and cofactors. The minor of an element of a given determinant is the determinant obtained by deleting the row and column through that element. We just consider an example: delta, that is equals to A11, A12, A13, A21, A22, A23, A31, A32, A33. So minor of the elements A11, and as per the rule, minor of an element of a given determinant is the determinant obtaining by deleting the row and column through the element. So A11, if we delete the rows through this element and we delete the column through this element, we get the determinant this A22, A23, A32, A33. And cofactor, what is cofactor? The cofactor of an element in a given determinant is the determinant obtained by deleting the row and column through that element with sign determined by the rule. For a second order determinant, rule first plus, plus, minus, plus, minus. For a third order determinant, plus, minus, plus, minus, plus, minus, plus, minus, plus. So therefore, as this is a third order determinant, A11, A12, A13, A21, A22, A23, A31, A32, A33. So therefore, cofactor of A11, that is equals to, it is denoted as capital A11, that is equals to A22, A23, A32, A33. Cofactor of A12, that is equals to capital A12, that is equals to minus of A21, A23, A31, A33. Next, addition of determinants. If each element of a row or column of a determinant is given as the sum of two terms, then the determinant can be expressed as the sum of two determinants. Example, here A11 plus B11, A12 plus B12, A13 plus B13, A21, A22, A23, A31, A32, A33. So this is can be expressed the sum of the two determinant. First determinant is A11, A11, A12, A13. Second row and third row is unchanged. And second determinant, first row considered as B11, B12, B13. Second row and third row is unchanged. So this can be written as A11, A12, A13, A21, A22, A23, A31, A32, A33 plus B11, B12, B13, A21, A22, A23, A31, A32, A33. If a column is in the sum form, that is A1 plus L1, B1, C1, A2 plus L2, B2, C2, A3 plus L3, B3, C3. Here first column is in the sum form, so this determinant can be expressed as the sum of the two determinant. First determinant we can obtain the first column by considering as A1, B1, C1, A2, B2, C2, A3, B3, C3 plus second determinant consider L1, B1, C1, L2, B2, C2, L3, B3, C3. Properties of a determinant. First property, the value of a determinant remains unaltered by changing its rows into columns and vice versa. That means to say that if we interchange the rows into columns, then value of the determinant is unchanged. Suppose D, that is equals to 7, 11, 3, 8, 0, 9, 2, 1, minus 1. This determinant can be expanded with respect to the first row. We get 7 into determinant of 0, 9, 1, minus 1, minus 11 into 8, 9, 2, minus 1 determinant, plus 3 into determinant 8, 0, 2, 1. And if we simplify, we can write 7 into 0 minus 9 minus 11 into minus 8 minus 18 plus 3 into 8 minus 0, that is equals to minus 63 minus a plus 286 plus 24, that is equals to minus 63 plus 0 310, that is equals to 247. And if we interchange this determinant, just like this here, interchange the column into row, first row converted the column, that is 7 11 3 written as the 7 11 3 first column, and 809, this is the second row written as second column, third row written as the third column. And if we expand this determinant with respect to the first row, we get 7 into 0 1 9 minus 1 minus 8 into 11 1 3 minus 1 plus 2 into 11 0 3 9. And if we simplify, we get 0 minus 9 minus 8 into minus 11 minus 3 plus 2 into 99 minus 0, that is equals to minus 63 minus 14 minus plus 1 1 2 plus 198, that is equals to minus 63 plus 0 carry 1 10 11 1 1 3, that is equals to 247. Here value of the determinant D equals to 247 and value of the determinant D1 is equals to 247. So if we interchange the rows into columns, value of the determinant is unchanged. Second property, if two adjacent rows or columns of a determinant are interchanged, the numerical value of the determinant remains the same, but its sign is altered. Property number 3, if two rows or columns of a determinant are identical, then the value of the determinant is 0. Property number 4, if each element of a row or column of a determinant be multiplied by the same quantity, then the determinant is multiplied by that quantity. Property number 5, the value of a determinant remains unaltered if each element of a row or column is increased or decreased by a constant multiple of the corresponding element of another rows or columns. Repeat this property. Always we apply the value of a determinant remains unaltered if each element of a row or a column is increased or decreased by a constant multiple of the corresponding elements of another row or column. Just consider an example: 2 1 minus 3 3 minus 2 4 5 3. Operate on first column, then the first column is changed, and there is a rule C1 dash, that is C1 minus 2 C2, that is corresponding element first column minus 2 into this column, 2 minus 2 into 1, 2 into 1, that is equals to 0. 3 minus 2 into minus 2, that is equals to 7. 5 minus 2 into 3, that is equals to minus 1. 1 2 minus 2. Sorry, third column also we can operate third column C3 plus 3 into C2. C3 equals to C3 plus 3 into C2 minus 3 plus of 3 0 4 plus 3 into minus 2, that is equals to minus 2 2 plus 3 into 3, that is equals to 11. Can be expand with respect to the first row, and if we expand the determinant with respect to the first row, we get minus 1 into 7 minus 2 minus 1 11. Expanding the determinant, minus of 77 minus 2, that is equals to minus 75. Let us consider another example. Delta equals to 10 2 6 5 minus 1 7 2 minus 3 8, and here we operate the first column such that C1 minus 2 C2, that is equals to 6 7 8 2 minus 1 3 6 7 8. Here first column and third column are identical, so value of the determinant will be 0. Next, rule of multiplication of determinants, same as matrix, as we previous discussed. The rule of multiplication in the case of a matrix. So I repeat you here: A1 B1 A2 B2 into C1 D1 C2 D2. Row column: A1 C1 plus B2 C2, A1 D1 plus B1 D2, A2 C1 plus B2 C2, A2 D1 plus B2 D2. Otherwise row or row column, anything else it can be just here. Thank you student. Like this video, subscribe my channel Easy Learning. Bye, take care.